I told you, my favorite example is this x squared. So I'm going to go ahead and use that. I'll show you how we're going to find the derivative using our new formula of our function x squared. How we plug it in, how we simplify it, and why it is so amazing. So what I'm going to do, using this function, so basic setup, the limit as h approaches 0, I guess I'm starting here. So my x value is x plus h. So I'm going to replace that here, x plus h squared. My x is literally x plus h, so I replace x with x plus h, minus f of x, which is literally f of x, x squared, all over h. If at this moment I plug in my 0, h equaling 0, I'm going to end up with x squared over x squared, which is 0, over 0. That's going to happen every time. That's the whole point. 0 over 0, we're finding the slope at one point. That's weird. So now we're going to go ahead and do the algebra to simplify this out. So my x plus h squared, I'll just kind of side this, x plus h times x plus h. X times x is x squared. X times h is xh. H times x is xh plus h times h, that's h squared. So right now I have x squared plus 2xh plus h squared. So I FOILed everything together, my x plus h squared, and this is what I have. So now I'm looking at the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. So we're just doing the algebra here to kind of simplify. And then what I see here is I have my x squared minus my x squared. That's going to go ahead and cancel out. Right? X squared minus x squared is 0. So now we have the limit as h approaches 0 of 2xh plus h squared all over h. My numerator, both terms have an h in common, so I'm going to go ahead and factor an h out. Factor the h out, which leaves me with 2x plus h all over h. Now I have h divided by h, which is 1. So that's going to reduce out, and I'm going to have the limit as h approaches 0 of 2x plus h. So now if I plug 0 in, 0 for h, that's going to give me 2x. 2x is the derivative of x squared. So we could write this in derivative notation. I could say f prime of x equals 2x. So now if I want to know the slope at 2, plug it in. 2 times 2, 4. Now I want to know the slope at 6. 2 times 6, 12. What's the slope at negative 3? 2 times negative 3, negative 6. All I have to do is plug my x value into my derivative formula, and I'm going to know the slope. Okay, good luck practicing.